Well, thanks very much, everyone, for coming, especially people who came a long way. And thanks also to the Cabot Institute and the University of Bristol for the opportunity to talk here. All right, Steve just did a really long introduction, but I might just continue it just a little bit. As Steve said, I come from the University of Queensland in Australia and actually work at the Global Change Institute. This is a picture of our new building, which is actually a really cool building. It's a zero emissions building. It uses modern technology to keep the building cool and comfortable without air conditioning and keep the emissions as low as possible. And it's really just a way of demonstrating ways that we can have a carbon neutral future. So it's a great place to work. I also run a website, Skeptical Science, which I started in 2007. And the purpose of this website is really quite simple. We debunk climate myths with peer-reviewed science. And lastly, I'm also a big cricket fan, and so I can't give a talk in England without at least showing a picture of the last time I was in England in June. Happily, it was cricket season, so I managed to get an actual game of club cricket, fulfilling a childhood dream, and even took 3 wickets. Or as I say to my friends whenever I'm describing this, 3 English wickets. So tonight I'm going to talk about a couple of things. I'm going to talk about our scientific understanding of global warming. I'm going to talk about what really interests me, which is how people think about climate change. And I'm going to talk about scientific consensus. Now, I think a great quote for a talk about scientific consensus is this one from John Reisman. And he says that science is not a democracy, it's a dictatorship. It's evidence that does the dictating. And what John is saying is that science isn't decided by a vote. It's not decided by popularity. Our scientific understanding is decided by evidence. So the way science works is we come up with hypotheses on how the world works, and then we test it with measurements. So what is our understanding of how global warming works? Now, Mike Ranney is a professor at Berkeley in California, and he ran an experiment a couple of years ago where he went into a park in California and just asked random people walking through if they could explain the mechanism that causes global warming. None of them were able to do it successfully. They were able to capture the mechanism driving global warming. And I read about this paper at around the same time that I was asked to give a lecture at the University of Queensland to second-year environmental engineering students. So I thought, well, yeah, maybe Americans wouldn't understand it, but I'm sure Australians could do better, particularly Australian university students. So I asked the class, who can explain the mechanism of global warming? And I was really looking for 2 elements to the mechanism. And the students kind of got halfway there, but they couldn't get both elements to the mechanism. So none of the students were able to explain it. So I thought, all right, well, Australia isn't doing so good. America wasn't doing so good. But while I was here in England, I thought I would extend the experiment a little bit further. And I gave a talk yesterday at the University of York. And so I thought, well, let's test the English, see how they go. And I guess you could kind of consider it a climate version of the Ashes. Could England outperform Australia? And one person did succeed in explaining it, but they had an American accent, so it didn't really count. So the climate ashes haven't really been decided yet. So I thought, how about we give it a try tonight? And I'm kind of springing this on the people with the microphones. But is there anyone in the room, no ringers from the States, who would like to have a crack at explaining the mechanism of global warming? I guess I should put a qualifier. I've been told that Bristol actually has the highest concentration of climate scientists in the UK. So no climate scientists who do this for a living either. I think, to make it equal. Does anyone want to have a crack at it? Anyone want to try explaining the mechanism driving global warming?
From my reading, looking at both sides of the argument, I'm not sure there is a mechanism. There are lots of papers that are produced You have the carbon dioxide theories, you have some of the natural warming theories. So I don't think there is actually one mechanism that's causing global warming.
Well, I mean, that's a fair comment. So I guess let me qualify that by saying, what would be the mechanism that's doing the bulk of the work? What's doing the heavy lifting, and how would you explain that? So a little bit further back over there. I mean, what you say, that's a really good comment, though, because it is true that there is no single driver of climate. There are many drivers, but at the moment there is one primary driver.
Okay, the mechanism is the greenhouse effect, which is the effect when light and infrared enter the atmosphere, certain gases, including water vapor and carbon dioxide, then trap the heat, so the planet warms up.
Okay, so greenhouse gases are trapping heat. Okay, all right, so I guess what you're saying is as we emit more greenhouse gases... Sorry, let me probe a little further, just to, like a good examiner. Hang on, I have a question. So we're adding more greenhouse gases, and that's trapping more heat, but if there's more greenhouse gases in the atmosphere, wouldn't that also be stopping more sunlight from getting in?
Not necessarily, because as the carbon dioxide or water vapor rises, the heat also melts ice caps, which have an albedo effect, and that's reduced because of the darker oceans. So more heat is then absorbed than would have been reflected out by larger ice caps.
Yeah, that's true, but I guess that's not quite... I feel like I'm being a bit of a nitpicking jerk here, but... okay, we'll have one more go over on the other side, because, yeah, that is half of the mechanism, but there's still another element to Tim, behind you.
More CO2 reduces the amount of outgoing long-range radiation from heat from the surface. So basically, it's a logarithmic effect. So as the carbon dioxide increases, if the carbon dioxide doubles, the warming goes up like some factor of log 2.
Okay, so again, I guess that you captured what the previous answer was, which was that outgoing heat is trapped by greenhouse gases. But what about, does that mean, why wouldn't there be less sunlight coming in? I guess that's what...
Carbon dioxide only traps radiation in a very small bandwidth of about 15 microns. The rest goes completely transparent, so that the sun is not unaffected. It's just the outgoing radiation from the sun, from the surface. So, and because it's saturated up in the troposphere, up in the stratosphere in the middle, it only affects the side bits of the spectra. So it really is a very small effect, but it is significant.
Okay, that was what I was looking for, so thank you very much. So I guess England does win the climate ashes. So. But Australia still has the real ashes, I'll remind you. 5-0, in fact. So I'll just recap that, okay? There's really two elements to the greenhouse effect, which was the effect that we were just discussing. Greenhouse gases, such as carbon dioxide, they're invisible to sunlight or visible light. So that means sunlight passes straight through the atmosphere and warms the Earth. Now, the Earth gets warm, and so it emits infrared heat, or infrared radiation, which is a different wavelength to sunlight. And greenhouse gases trap infrared heat. And this is really the driving mechanism behind the greenhouse effect. It lets sunlight in, it traps infrared heat. It's kind of like a one-way valve. Now, we're emitting more greenhouse gases into the atmosphere, and that means that more infrared heat is being trapped, but the sunlight is still being let in at the same rate. And this is what's the main mechanism driving global warming. Now, this is our understanding of, this is how scientists think that global warming is happening, but how do we know that it really is happening? How do we test our understanding? And that's where we can use measurements to test our understanding of the science. Now, the beauty of science is if you can make predictions from your understanding, then you can test them with observations. So one of the predictions you would expect if greenhouse gases were causing global warming is we should see less heat escaping out to space. And satellites have been measuring outgoing heat since the 1970s, a whole series of different satellites. And what they're finding is less heat escaping out to space at the exact wavelengths that greenhouse gases absorb heat, particularly carbon dioxide. So if there's less heat escaping out to space, that should mean there's more heat coming back down to the surface. And we have a range of devices all across the planet measuring infrared radiation coming down from the atmosphere. And what they find is, just as we expect, more heat returning back to Earth. Now, another prediction of greenhouse warming, which was actually predicted back in the 1960s before we started measuring this, is at the same time that the lower atmosphere should be warming, we expect to see the cooling in the upper atmosphere. This is one of those fingerprints of greenhouse warming. And this has also been observed by satellites, by weather balloons. And because the atmosphere is cooling in the stratosphere or in the upper atmosphere, we should also see it shrinking. And so satellites which are brushing the top of the atmosphere are actually measuring the atmosphere falling below them. And there are a whole range of human fingerprints that we expect to see in our climate system. Some of them were predicted as far back as the 1850s. John Tyndall predicted that winters should be warming faster than summers and nights should be warming faster than days. This was in 1859. And just in the last decade, scientists have been measuring these patterns that we expect to see from greenhouse warming. So we have all these multiple lines of evidence pointing to a single conclusion. We have a consensus of evidence. And the result of the consensus of evidence is a consensus among the scientific community. Now, there's been a number of surveys or studies trying to measure the level of agreement amongst the climate science community about whether humans were causing global warming. The second one, was by Peter Doran, who did a survey of about 3,000 or 4,000 Earth scientists, asking them, are humans significantly changing global temperature? And what they found was quite interesting. They found that as the scientists' expertise in climate science grew, so too did the level of agreement about human-caused global warming, to the point where when you got to climate scientists who are actively publishing peer-reviewed climate research, there was a 97.4% agreement. I think that was the figure. We'll find out on the next slide. Now, a year after that study, in 2009, William Anderegg did a study where they looked at public statements by scientists about global warming and looked at whether the statements endorsed the IPCC position on global warming, which was that humans were causing most of global warming since the middle of the 20th century, or in other words, humans have caused at least 50% of global warming since 1950. And they looked at statements that endorsed the IPCC position or rejected the position. Then they had this list of scientists, and then they looked at which of the scientists had published peer-reviewed climate papers. And they found that among the scientists who had published peer-reviewed climate research, there was 97.5% agreement. Now, this level of agreement among scientists is actually quite extraordinary. And there's a great quote from a climate scientist which sums this up. This is a quote from Peter Cox. This is actually a series of quotes that I published on Skeptical Science last week, where we looked at 97 quotes from 97 climate scientists. And because I'm a glutton for punishment, I also drew 97 caricatures of these 97 scientists. Fortunately, a lot of the scientists have interesting facial hair, which made it quite, facial hair is really a dream for a caricaturist. And this was actually my favourite quote amongst the whole 97. The idea that scientists are like cats, you can't herd them. And in fact, I was at a climate science conference and I watched a handful of climate scientists spend about an hour arguing over where to go for beer. after the poster session. And I think that the term Intergovernmental Panel of Cat Control is one of my favourite terms, and I'm keen to get it out there, used as widely as possible. And it's the idea that scientists, by their very nature, question and are sceptical and like to disagree. So to get scientists agreeing to the level of 97% could only happen if you had many lines of evidence all backing up the consensus position. So I guess the next step in measuring consensus was a study that the Skeptical Science team and I did over the last couple of years, and it was published in the middle of 2013, May last year. And what we did was we wanted to measure the level of agreement about human-caused global warming in peer-reviewed climate papers. So we did a search over 21 years of papers about global climate change or about global warming. We identified all the abstracts that stated one way or the other whether humans were causing global warming. There was about 4,000 abstracts that stated one way or the other. And among those abstracts, we found that on average, 97.1% of them endorsed the consensus. So this blue line across here was us, our measurements of the abstracts across the 21 years. So the horizontal axis on this graph is the years. The vertical axis is the level of consensus. And we see that even as far back as the early 1990s, there was overwhelming agreement in the peer-reviewed literature that humans were causing global warming. We also asked the scientists to rate their own papers about whether they endorse the consensus or not. And that's the green line. It gets a bit wobbly towards the early 1990s because we just didn't get many scientists responding to our survey that far back. Firstly, there weren't that many scientists back then, and secondly, a lot of the emails that were defunct by that point. So it was just hard getting track of scientists to fill it out. But as you get further along, the agreement strengthens between our results and the scientists rating their own papers. So overall, the third one here shows our results. Among relevant climate papers, there's 97.1% agreement that humans are causing global warming. And then when we asked the climate scientists to rate their own papers, amongst papers that were self-rated as stating a position on human-caused global warming, there was 97.2% agreement. So many different studies looking at this angle from different ways, using different definitions of consensus, and using different types of analyses, all find that there's an overwhelming level of agreement among the climate science community that humans are causing global warming. Now, after our paper came out, the day after, we were quite surprised when President Obama's Twitter account tweeted about our paper. And then a couple of days later, he tweeted again. And then a few weeks after that, he gave a speech about climate change. And this speech was made on a hot summer day, so he was taking his jacket off as the sun bore down on him. He was mopping his brow constantly through the speech, rolling up his sleeve. If the speech had gone much longer, we probably would have found out whether he was a boxers or briefs president. And he also talked about the 97% level of agreement among climate scientists. And this was a powerful step towards raising awareness amongst the public that humans were causing global warming, because part of my research has been measuring what the public think about the level of agreement among climate scientists. So I've run surveys, a number of surveys over the last 3 years, asking representative samples in Australia and America, asking them to estimate what percentage of climate scientists agree about global warming. And what I found is, on average, the public think it's a 50-50 debate. When I asked a representative sample in the middle of 2013, I got 55%. So the public think there's a 50-50 debate when, in reality, there's 97% agreement. Now, why is there such a big gap between public opinion and the 97% reality? part of the reason, and it's a complicated answer, but one contributing factor is the fact that over the last several decades, there's been a steady stream of misinformation specifically looking to cast doubt on the consensus. And we can go back to the late 1980s. In the early 1990s, in 1991, Western Fuels Association spent $500,000 on a campaign specifically designed to cast doubt on the consensus. And if we look at this little, let's hope I get this right, this little bit here refers to an analysis of articles published over a 4-year period, 2007 to 2010, looking at syndicated conservative articles about climate change and looking at the various myths promoted in these articles. And what they found was the number one myth used over this 4-year period was there is no consensus, attacking the consensus. So it's been a major focal point from people who were opponents of climate action. A major focal point has been to cast doubt on the science and cast doubt on consensus. Now, why are they doing that? A quote here from 2002. This is from a political pollster who provided advice to politicians during an election in America. And this is what he's telling politicians the strategy to do to decrease public support for climate action, or decrease public support for policies to mitigate climate change. And what he's basically saying is, if the public realise that all the scientists agree, then their views about climate change will also change accordingly. And if you want to keep public support for climate action down, then you need to cast doubt on the consensus. You need to make sure that the public think that there is no consensus among the scientists. So this is why consensus is important. Now, it actually, when you think about it, it actually makes a lot of sense that public perception of consensus is strongly linked to public support for climate action, and it's also strongly linked to just our general attitudes towards climate change. Because when it comes to any complicated scientific topic, people use expert opinion as a heuristic or as a mental shortcut to form their views on the science. And it's not just about climate change, it applies to any complicated area of science. To give an example, if you're driving towards a bridge, you don't pull over, get your phone out and start looking at bridge building blogs or engineering blogs and thinking, all right, I better work out whether this bridge is actually safe or not. You rely on the experts who built the bridge. You trust in the engineers and the designers that they knew what they were doing and that they built a safe bridge. And so this heuristic or mental shortcut makes a lot of sense in most cases. And so that's really a driving factor behind people's attitudes towards climate change, what they think about what the scientific experts think. And so this brings a really important point about scientific consensus on climate change. Communicating the consensus isn't about proving climate change. We know that humans are causing global warming based on the many lines of evidence. What it's about is addressing a public misconception about expert opinion. And it's a public misperception that actually is one of the main drivers of people's attitudes towards climate change and about climate action. Now, after our paper came out, for the 18 months since it's come out, there's been about 300 articles published online attacking our paper. There's been blog posts, there's been a number of cartoons. I think that's me on the left. That's Dana Nucitelli on the right. I don't think he has a monobrow, but the internet says otherwise. There's been YouTube videos, there's been a number of reports produced by conservative think tanks. And strangely, there's been a number of conspiracy theories. And the conspiracy theory that we were actually in the pay of fossil fuel, was the one that we didn't see coming at all, and I'm still scratching my head over that one. Now, for somebody whose research is about attacks on science, for my science to then get attacked, well, I guess I don't really see it as attacks. I see it more as data. And I don't know any scientist who complains about getting too much data. So I think it would be ungrateful for me to complain about all the attacks being directed towards my scientific research. And what they actually do is, I find them quite instructive, because there's been studies that look at movements that reject a scientific consensus, whether it's about climate change, about evolution, about the age of the universe being more than 6,000 years old, or about smoking being linked to cancer. And what all these movements share in common are 5 different characteristics or techniques. And here are the 5 techniques. I've got an acronym. I wouldn't even be able to remember it without the acronym. So that allows me to actually say them without looking over the slide. So there's this fake debate is one of the most popular ones. It's a way of trying to give the impression of an ongoing debate when the climate or when the scientific community has already agreed on an issue. There's logical fallacies, which is just using logically false arguments to distort the science. There's impossible expectations or impossible standards. And the tobacco industry I guess, perfected this technique back in the 1970s when they demanded ever higher standards of proof that smoking caused cancer in order to delay regulation of their industry. There's cherry picking, which is looking at small parts of the body of evidence and ignoring the bigger picture. And lastly, there's conspiracy theories. When you disagree with the whole global community of scientists, inevitably you're going to end up resorting to conspiracy theories to explain why. Now I'm going to look at just one of these today, and that's the first one, fake debate. Now, I could explain it, but there's someone who actually explains it a lot better than me, and that's John Oliver, who's a comedian, British comedian, based in the US. And this is one of the best pieces of climate communication that I've actually that I've seen. And here he is talking about the technique of portraying this impression of an ongoing debate. And fingers crossed it'll work okay.
A survey of thousands of scientific papers that took a position on climate change found that 97% endorsed the position that humans are causing global warming. And I think I know why people still think this issue is open to debate, because on TV it is. And it's always one person for, one person against. And it's usually the same person for.
Bill Nye and Marsha Blackburn, welcome both of you to Meet the Press.
Bill Nye joins us now, along with climate change skeptic Mark Morano.
Joining me now to go head-to-head, Bill Nye, science educator and CEO of the Planetary Society.
In the crossfire, Bill Nye, the science guy.
Bill Nye, the science guy, who believes in man-made global warming.
Yeah, that's right. More often than not, it's Bill Nye, the science guy, versus some dude. And when you look at the screen, it's 50-50, which is inherently misleading. If there has to be a debate about the reality of climate change, and there doesn't, then there is only one mathematically fair way to do it.
Last Week Tonight presents a statistically representative climate change debate.
Good evening. Joining me tonight, a climate change denier and, naturally, Bill Nye science guy. Bill.
John?
Yep.
Humans are causing climate change? No question.
Wait. Before we begin, in the interest of mathematical balance, I'm going to bring out 2 people who agree with you, climate skeptic, and Bill Nye, I'm also going to bring out 96 other scientists. It's a little unwieldy, but this is the only way you can actually have a representative discussion. So, yeah, please file in. Again, this is going to make the debate difficult. We shouldn't really be having it in the first place. But, so, representationally, climate skeptic, please make a case against climate change.
Well, I just don't think all the science is in yet. It's settled.
Okay, and what is the overwhelming view of the entire scientific community? Okay. Any response to that? Any response? I can't hear you over the weight of scientific evidence. This whole debate should not have happened. I apologise to everyone at home. My thanks to Bill Nye and the overwhelming scientific consensus.
So there you go. It's got about 4 million views, this video, which is fantastic. Not as many as cat videos, but still a pretty good effort, I think. Now, I'm going to look at another example of casting doubt on the consensus and just trying to understand the techniques being used. Not as, feels a bit of a letdown after John Oliver, actually, but just bear with me. Now, what do you do if there's a 97% level of agreement among climate scientists, but you want to portray the impression of a 50-50 ongoing debate? One thing you can do is use fake experts. And the most common example of this strategy, or the most widely used, is the Global Warming Petition Project, which is a website that has 31,000 scientists who have signed this statement saying that humans aren't disrupting climate. Now, if we've got so much agreement amongst the climate scientific community, why is there 31,000 scientists signing this petition? How do you reconcile those two facts? And the answer is that 99.9% of the people who have signed this petition aren't climate scientists. All you need is a science degree to be qualified to sign it. So what we find on this list is mechanical engineers, doctors, computer scientists, but very few actual climate scientists whose expertise is researching the climate. Now, as part of my research, I decided to examine what impact this kind of misinformation has on people's views on climate change. And so as part of a randomized experiment, I showed this information to people. Don't worry, after the experiment, I debriefed them to explain how it is actually misinformation to undo any damage that the experimental design might have had. But I was mainly interested in seeing how people would react to this information. So they read this, then they filled out a survey, just looking at their beliefs in various aspects of climate. And what I found was these results. Now, I'll do a little bit of explanation. The red line here is the change in belief. So the dotted line here is 0. So if the red line is there, it means there was no change in belief. And anything negative means their belief went down. So on the vertical axis here, this is the change in belief about the consensus, or in other words, the change in their perceived consensus. So if it went down 0.2, that's 20%. So they might have gone from thinking it was a 50% consensus down to a 30%. Now the horizontal axis, it was support for the free market, which we use as a measure of political ideology, essentially asking them questions about their level of support for a free, unregulated market. And we find that that's quite a robust measure of people's political ideology. So as you get further to the right, you get a stronger support for the free market, which is equivalent to more politically conservative. And so what we found was, as people got more conservative, the misinformation had more of an effect in lowering their perception of consensus. So people at the liberal end of the spectrum the misinformation had no effect, whereas people at the conservative end lowered their perceived consensus by about 20%. We also measured their policy support or their support for climate action. And we found a similar pattern, not as strong, which is to be expected, but we found that conservatives lowered their support for climate action in response to just hearing that the 31,000 scientists dissented. Now, the other part of the experiment was, for another group, we showed them this information before they read the misinformation. So this was like a primer. And there's really three elements to this primer. Firstly, we introduced them to the technique of fake experts, of using spokespeople who didn't have expertise in that issue, but they had the appearance of having expertise. And then I used an example of the tobacco industry. They actually had a strategy called the White Coat Project, where they had spokespeople in white coats saying that smoking was good for your throat, or it soothes the throat, or there's no danger from smoking, as a way of trying to convince the public that there was still scientific debate about the link between smoking and cancer. And then we joined the dots between that strategy and the fact that the same strategy was happening with climate change, that fake experts were being used to cast doubt on the science. Now, we didn't mention, in this primer, we didn't mention the global warming petition project. We didn't mention the 97% consensus. It was really just about explaining that fake expert strategy, then showing them the misinformation, and then measuring their climate beliefs. And this was the result. Now, so the red line was just the misinformation people. The blue line is a change in belief for people who were primed or who had the technique of the misinformation explained to them. And what we found was the misinformation was completely neutralised. At the liberal end of the scale, the distance between these two is statistically insignificant, which means there's no real difference between at the liberal end of the scale. They weren't affected by the misinformation either way. But at the conservative end of the scale, there was actually a slight backfire. People actually increased their perception of consensus when they were explained about the fake expert strategy, and then they were exposed to the actual fake expert misinformation. And we saw the same pattern with policy support. So there was no effect at the liberal end, but at the conservative end, once they understood the fake expert strategy and they saw through the misinformation, then the misinformation backfired. And this, the lessons from this research was really that explaining the techniques of misinformation and the techniques of science denial is an effective way of neutralising the effects, neutralising the influence of misinformation. And it can even cause misinformation to backfire slightly. Now, there's other strands of research that have looked at this kind of approach from different ways. There's inoculation theory is a branch of psychology dating back to the 1960s that have looked at the idea of information in the same way we think about flu vaccinations. So what they found was if you expose people to a weak form of misinformation, then it gives them immunity or resistance to real misinformation when they encounter it. And there's another branch of research in the education research literature that looks at something called agnotology-based learning. Agnotology is the study of misconceptions or ignorance. And agnotology-based learning is just teaching people in the classroom by addressing misinformation and misconceptions. And that's a really important part of education because it's not just about pouring new information into people's heads. It's also about correcting incorrect information. And directly addressing misconceptions is the most effective way of doing this. So what I'm currently working on at the moment with Skeptical Science and with the University of Queensland is tying together all this research that I've been doing, research into inoculation theory, research into agnotology-based learning, and what we're developing is a MOOC, or a massive online open course, which looks at all around 50 of the most common climate myths, explains the science relevant to each myth, but importantly, also explains the techniques used to cast doubt on the science or to distort the science. And the basis of that is all this research, that explaining the techniques of misinformation can neutralise the misinformation or even cause it to backfire. So the MOOC actually just, the registration page opened a couple of hours ago. There's the web address at the top. If you go there, it redirects you to the registration page. The MOOC actually starts on the 10th of March, and part of being in England is I've been interviewing climate scientists and recording lectures with some of the English members of the Skeptical Science team, and just putting together this MOOC addressing climate myths. So I thought I might, I think we've got plenty of time for questions now, and I thought I might put it to the audience if anyone wants to ask questions about the research or about consensus or about climate change. And while you were going through the questions, I think I'll just leave this pandering slide up, which features a caricature of the director of the Cabot Institute, Richard Pankhurst. And I note that he's wearing right now the same clothes that I drew, although he doesn't have the same red tie, unfortunately. So yeah, thanks very much.